Welcome, my name is Jan-Ove Hennig. You might also know me by my alias, Kabuki. In this video, I would like to explain how I use Ableton Live to create complex structures from a simple seed, using a recent production as an example. Almost all of the sounds you will hear are going to be generated by the Meld synthesizer, which provides a lot of versatility with its different oscillator models. I will also break down a simple, custom-built Max for Live device that generates beautiful monophonic tapestries from chord blocks. Let's dive right in. First of all, let me introduce you to the structure of this project. It all started with a particular chord progression that I came up with during one of my writing sessions. Let's hear the MIDI clip. On some days I might only write chord progressions, while on other days I only program drums or synthesize sounds. When listening to this later, I realized it would build a strong backbone for a synth-heavy instrumental hip-hop track. I then picked a matching drum kit and recorded the beat and the bass line. Chord progression and these elements serve as the origin point for my production process. I begin by breaking down the chord progression into individual voices, starting with the foundation, the root note. For the first layer, I'm going to create a massive monophonic sound using multiple instances of the swarm saw model. Let me show you how I'm using this approach to create complementary timbres and tones. Let's select the root notes of the chords by holding down the Shift key. Once all root notes have been selected, I invert the selection using the shortcut Command-Shift-A. Then I mute these notes using the 0 key shortcut. Now that the note material is prepared, it's time to shape the sound. I will first focus on Engine A, for which I select the Swarm Saw model from the drop-down menu. Next, I set the mode of the device to mono, so that there will be no overlap between notes, which is especially relevant for sounds covering the low end of the spectrum. I deselect legato mode so that the envelope will be retriggered each time a new note is played. Next, I dial in the envelope. Since I plan to eventually add Engine B to the mix, I link both of them. I want this sound to gradually fade in, so I set the attack value by typing in 1000 into the number box. Now it's time to define the timbre by setting motion to 30, which slightly detunes the individual oscillators. Spacing will be set to 50, which creates a rich timbre with the swarm oscillators forming a big power chord, with fifths and octaves covering a wide range of the spectrum. I want this engine to live in the high end of the spectrum, so I use the 12 dB high-pass filter engine and set the cutoff to 250 Hz. I also add overtones by setting drive to 50%. Since this increases the amplitude, I decrease the volume to 9 dB to avoid clipping. As a next step, I will add Engine B to the mix. Let's mute Engine A for the time being and select the Swarm Saw model for Engine B. While we play the clip, let's set the macro controls to 30 for motion, but spacing only to 20. This will create a lower octave. We keep the 12 dB state variable filter, but set this to 750 Hz to highlight the low end. This way, layer B adds contrast to layer A. Let's add Engine A to the mix and listen to the result. Now that the individual components have been dialed in, it's time to add the finishing touches to the patch as a whole. I access the Settings tab on the device and set the portamento for both engines to 240 milliseconds. To activate portamento, I let all notes overlap with the exception of the ones right before the turnaround. Layer 4 adds even more density by playing a reduced version of the chord, this time adding the top note into the mix. Now it's time to work on elements that provide a framing for the chord progression. To add contrast to the pad layer, I will break up the polyphony using the strum function. For this layer I will use a wavetable sound, and there's a preset I have in mind for this. I want to shorten the time the chords ring out, so I access the extended clip properties. Here I select the note division of 1/16 and click Set Length. After selecting Strum from the drop-down menu, I'm now able to change the spacing of the individual notes. Strum essentially creates a ramp that plays back the notes in ascending order, and I can control the duration of this ramp with Strum High. I pitch up the notes 1 octave by selecting all notes using the shortcut Command A and then Shift Arrow up. Now it's time to adjust the sound. Now that the harmonic foundation has been laid, it's time to develop melodic content from the chords. For this, I will use a combination of the stock Ableton arpeggiator and a custom-built Max for Live device that generates rhythmic motifs by skipping notes of the otherwise steady arpeggiator pattern. I will start working on this track by duplicating the source material, this time by holding the Option key while dragging it. Next, I transform the polyphonic chords into monophonic arpeggio lines. I select Arpeggiate from the drop-down menu. I keep the button Transform highlighted so that all changes are reflected instantly. I will set the arpeggiator to 8th notes. For the distance, I will keep 12 semitones and a 2-step setting. Finally, I will set the style to Converge for a little less conventional arpeggiation pattern. Next, I start to work on the sound of this particular layer. I select the Fold FM engine, which is one of my favorites. I set the amount to 20 and shape to 10. The beautiful artifacts in the higher register are exactly what I was looking for. To have a less static timbre, I will select the low-pass Crunch 12 dB filter and set it to around 1750 Hz with a resonance of 50 and a drive of about 15. I would like to modulate this with the LFO, which I assign in the Matrix tab with about 30 to the filter cutoff. The effect is not yet audible. For this I will have to change some settings in the LFO tab. I need to deactivate retrigger. Activate sync. Then I change the shape to ramp, set the shape to 80, and slope to 50 for an interesting variation of a rising ramp. Now it's time to transform the steady 16th note pattern into a more interesting motif. For this I'm going to load the skipper, a Max for Live device I built specifically for this purpose. What the skipper essentially does is skip MIDI notes based on a simple rule. There's a sequence of values from 0 to 5 represented by these horizontal bars. Next to it you see a threshold slider, which lets fewer or more notes pass through the gate. At its lowest setting, the threshold lets every MIDI note through. But the higher the threshold value, the less steps pass. The reason why this is important for me is because it is not random, but rather produces a repeating sequence. While the chords underneath change, the sequence of skipped notes remains the same. When a device is loaded, a new sequence is automatically generated. However, if I would prefer a different sequence, I can also trigger new variations with the button on the left until I find one that I like. Let's hear it in action. I've created a skipper in a way that is fairly self-explanatory and easy to grasp. So let me explain the functionality of this device in more detail. From my experience teaching Max MSP, I know that there's a certain amount of respect when it comes to looking under the hood of a device. So I've created a skipper in a way that is fairly self-explanatory. It's important to understand that while editing a Max for Live device, not all changes made in a Max editor will be automatically reflected in the device, and vice versa. My best practice when editing a patch is stopping the sequencer and focusing on the Max editor. Once I'm done, I save the patch, after which the Max for Live device is up to date again, and I can evaluate my work. First, we need to click the Edit button in the top right corner of the device. This opens the Max editor where the patch will be displayed. When the Max editor first opens, I see the same panel that's also visible within Ableton. This is called the presentation mode, and can be thought of like the front panel of a synthesizer, with only the controls visible that are required for the manipulation of the device. When I now click this icon at the bottom of the window, the view switches to patching mode, which is often where beginners lose faith. But fear not, I promise you will understand what's going on under the hood of this device, and who knows, you might even be inspired to build your own. Let's maximize the window and investigate. At the core, a Max patch consists of so-called objects, which are connected with patch cords. There are a multitude of objects, including buttons, sliders, number boxes, mathematical operations, interface elements, you name it. I intentionally kept this patch simple with few objects to understand. The patch is separated into 4 distinct sections. Threshold is where the value is set that determines which notes will be skipped. List is where a list of skipped values is generated and compared with a threshold value. Counter is where incoming notes trigger a counter that goes from 1 to 16, which is then used to step through the values in the list. MIDI notes is where the incoming MIDI data is transformed into note information and passed through a gate that opens and closes depending on the threshold value for this particular step. Simple, right? Let me lock the patch by clicking the icon at the bottom left so that I can interact with the controls and explain their functionality. Let's start breaking down the patch by looking at the list section. When loading the patch for the first time, the load bang object is triggered. This object is useful for initializing a patch so that it functions in a specific way. In the case of the skipper, the load bang triggers an Uzi object. The team behind Max MSP likes colorful analogies, so an Uzi actually fires off a series of triggers, specified by the integer argument in the object box. I can test this by clicking the button above the Uzi object, and a new list of 16 random numbers appears below. Moving one line lower shows that the Uzi is connected to a random object. As the name suggests, this produces a random number, and the argument 5 determines that it should generate random numbers in the range between 0 and 4. It is important to understand that some objects in Max are 0-based, as it is the case with a random object. This means that they don't start counting from 1, but rather from 0. Let's verify this by triggering the bang button above the random object. You can see that with each trigger, a new random number is generated. The object below, called ZL group, groups individual items into a list. In this case, a list of 16 integer values. We can confirm this by manually generating more random values until a new list is completed. This is then displayed numerically in the message box below and graphically using an array of 16 sliders, with the value 0 at the bottom and the value 4 at the top. These sliders are also what is displayed as graphical interface in the presentation mode within Ableton. The list of values is then stored in an object called ZLEnth, that allows us to extract items from a list based on their index. We will get to this in a minute. At the bottom of this section, you can see that the list value is arriving at the left inlet of the larger than or equal object, and the threshold value is arriving at the right inlet. Let's venture further up the patch window to the threshold section to understand where the threshold value is generated. Here, a slider produces integer values between 0 and 4. You can see this in the number box below the slider when I move it. With this knowledge, it's clear how the equation determines whether a step should be played or skipped. For example, With a skip value of 2 and a threshold value of 4, the statement that is being evaluated reads, "Is 2 greater or equal than 4?" This is obviously false, or in Boolean logic expressed as 0, which is displayed in the number box below the object. We can test the functionality by manually changing the skip values and observing the results. To understand how this number is used to skip notes, we have to venture further down to the left of this patch. Here you see the gate object that takes one input and sends it to either of its outlets. The outlet is selected by the numerical value arriving at the leftmost inlet. The number 0 selects the left outlet and the number 1 the right outlet. This means that the result produced by the larger than or equal objects opens or closes the gate, resulting in the skipped notes. Let's move to the top of the MIDI notes section to understand how the incoming data is processed. First of all, the MIDI in object outputs raw MIDI data that arrives at the input of the Max for Live device. In order to process this further, I need the MIDI pass object, which transforms the raw MIDI data into standard messages. The leftmost outlet outputs a list consisting of pitch and velocity. For instance, if I press middle C at the highest velocity, it will produce the list 60, 127. When I let go of the key, it produces the list 60, 0. In this case, 60 represents the MIDI note number for middle C, and 127 and 0 the respective velocity values. In order to further process the list, I need to separate it into individual pitch and velocity values, which is done using the unpack object. The arguments I tells the object that we expect 2 integer values. If we move to the bottom of this section, we can see that the MIDI note and velocity informations are sent to the note out object, which reassembles them into raw MIDI data that is outputted by the Max for Live device and received by the instrument, in our case the Meld synthesizer. However, the note out object only sends MIDI data when a new MIDI note number is received at its leftmost inlet. Gating the MIDI note and only letting it through when the skip value exceeds the threshold value is how this patch functions at its core. Not so complicated after all, right? In order to fully understand the patch, we still have to investigate how the index for the ZL-nth object is created that we talked about earlier. To do so, we move back to the unpack object and follow the patch cord that is connected from the velocity number box. This is connected to a select object with the argument 0. Here, a patch cord is connected to the rightmost outlet that sends a bang when the argument doesn't match the criteria. In other words, when the input is not 0. Why is this the case? Simple. As we saw earlier, each MIDI note produces 2 velocity values, a non-zero value when the note is triggered, and a 0 value once it is released. Since we want to move forward through the list of skip values only at the onset of every incoming MIDI note, we have to filter out the note off messages to avoid double triggers. Selecting any velocity information that is not 0 will produce accurate results. All note on events then produce a bang, which is used to drive a counter object. Let's trigger the bang object to see this in action. The resulting count is then forwarded into a trigger object, which is used to sequence actions in a specific order. Actions are determined by the arguments B, which stands for bang, and I, which stands for integer. It's important to understand that the order of actions on Max is always from right to left. This means that the incoming value from the counter is first sent to the right inlet of the Z-nth object, where it is stored as the index to be queried. Then, as the second action, a bang is sent to the left inlet of the Z-nth object, which produces the value found at this specific index of the list. When we manually trigger the counter object, we can confirm the logic by checking the skip value that is produced by the numbers in the list. Accurate. The very final section of the patch to investigate is at the top of the counter section. The plug sync object provides information of the Ableton host application status, and each of the outlets can be used to monitor specific information, such as tempo or bar count. I'm interested in the state of a transport. Why? Because I want to make sure that every time the transport is started, the counter in this patch starts from the beginning. The way I'm doing this is simple. Whenever the counter is stopped, the plug sync object outputs the value 0 from its leftmost outlet. Since it outputs this number continuously, I use the change object that only generates an output when the input changes its state. In other words, from 0 to 1 or from 1 to 0. Then I'm using the select object again with the argument 0. I connect the leftmost patch cord that produces a bang when the value 0 arrives at the input. In other words, when the transport is stopped. In this case, a bang is sent to the third inlet of the counter object, which resets the count to 1 at the next trigger it receives. This means that when the transport starts, the counter will also correctly start from 1. And this is the complete functionality of the patch. Hopefully this gives you the courage to create your own device when you feel inspired to solve a particular creative problem next time. Let's listen to the sequence in context with the rest of the layer. Notice that I'm doing a few last-minute tweaks, namely setting the amplitude release value to around 600 milliseconds and adding a drive of around 20%. I created 2 additional arpeggio layers based on the same principles that I explained earlier. Let's listen to all arpeggio layers together. The final step of the process is combining the individual elements into a meaningful arrangement. For me, the key is having the ability to apply filter, volume, and send effect automation to several tracks at once by combining them into groups. With this approach, I'm able to overlay additional manipulation independently of the material contained in the MIDI and audio clips. I like to think of this approach as having the tracks laid out on the mixing board and controlling the faders and knobs while the recorded material plays back from tape. In closing, let me thank you for watching. I hope you find inspiration in this video in the same way that I've been inspired by the creative process of other artists. You can download the Max for Live device and listen to the full track by following the link in the description.